Here, what's going on, guys? Let's look at this problem right here. Here this question is asking, consider a silicon sample doped with Nd is equal to 1 times 10 to the power of 15 per centimeter cube donor atoms. Assume that the intrinsic carrier concentration Ni is equal to 1.5 times 10 to the power of 10 per centimeter cube. If the sample is additionally doped with Na is equal to 1 times 10 to the power of 18 per centimeter cube acceptor atoms, the approximate number of electrons per centimeter cube in the sample at T is equal to 300 Kelvin will be what? Okay, so here they are asking for the electrons per centimeter cube. Initially we have intrinsic semiconductor, but if you dope an intrinsic semiconductor, that's going to become extrinsic semiconductor. And in extrinsic semiconductor we are going to have majority carriers and minority carriers. After we doped with this Nd donor atoms, we are going to have this one. This is going to be our majority carrier, right? So we can say after doping with Nd number of donors, majority carriers approximately equal to Nd, that's going to be 1 times 10 to the power of 15. Okay, so it's basically the donors added. Now the next thing is they are saying, assume that the intrinsic carrier concentration Ni is equal to 1.5 times 10 to the power of 10 per centimeter cube. If the sample is additionally doped with Na, that's equal to 1 times 10 to the power of 18 per centimeter cube acceptor atoms, then we have to find out what's going to be the electron number. Now here you can see we are additionally adding Na, right? So now the majority carriers is going to be depends on whichever the value is higher. Now let's go ahead and see. To calculate this one, we have to use this equation, majority carriers, that is approximately equal to Nd minus Na. Nd is the number of electrons, Na is the number of holes, because acceptors are holes, donors are electrons. Okay, now if you look at this one, we have Nd that is 1 times 10 to the power of 15 and Na that is 1 times 10 to the power of 18. So whatever the big value, that's going to remain the same, because comparatively this is going to be neglected when you subtract, right? So Na, this is like negative doesn't matter because this is a magnitude, so we can write the Na first. So 1 times 10 to the power of 18 minus 1 times 10 to the power of 15. And you can see if you subtract from this one to 1 to 10 to the power of 15 from 10 to the power of 18, it's not gonna change this one much. So because it's 1000 times bigger than this one, right? So we can just approximately write this is equal to 1 times 10 to the power of 18 holes per centimeter cube. So this is going to be the majority carriers. Now we are interested in finding what's going to be the number of electrons per centimeter cube. Now we found out the majority carriers are holes, so we have to find out what is the minority carriers, because that's going to be the electrons. That's what we are interested in. Now to find the minority carriers, we can use the mass-action law. Okay, mass-action law. Let's go ahead and create the equation. Carriers. So mass-action law says that n number of positive carriers times, or you can say electrons, number of total electrons times number of total holes multiply should be equal to intrinsic carrier concentration square. Okay, here we are interested in finding the number of electrons per centimeter cube. So that is n. So that's going to be what? Ni square divided by p. We already know the p value, that is 1 times 10 to the power of 18 holes per centimeter cube. Ni square is going to be this one, 1.5 times 10 to the power of 10 square. So if you plug in this equation, we are going to get this final answer. So Ni square, instead of writing holes, we can write majority, because we know that majority is the holes. So we can say majority, and that's going to be what? 1.5 times 10 to the power of 10 square divided by the majority, that's 1 times 10 to the power of 18. And if you square this one, you're going to get 2.25 times 10 to the power of 20 divided by 10 to the power of 18. And this one cancels. We will get 10 to the power of 2, and if you multiply 2.25 times 10 to the power of 2, you are going to get 225 electrons per centimeter cube, and that's going to be the minority carriers. That's going to be the final answer. That's going to be the number of electrons per centimeter cube. 225 electrons per centimeter cube. And that's how we do this kind of problems. I hope this helps. Thanks for watching.